You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Well, hey everybody, welcome to the show. Good to see you guys.
Good to see you too.
Hey, good to be here.
Love it.
I am starting things off this week. And obviously you two are still working as naturalists. I'm not. I don't know about other states, but
in your
pretty
heart,
much every
you
nature.
are.
Yeah, in my heart I am. Pretty much every nature center in Minnesota has a collection of reptiles and amphibians, our ambassador animals, right?
Right, yeah.
Mm-hmm.
Yep.
And their terrariums give visitors something fun to look at, but also many of the animals are used in educational programs. It's a really great way to engage kids and teach about different types of animals and their different adaptations and stuff.
Absolutely, yeah.
Yeah.
And as you guys know, one of the most common animals that we use is the American toad.
Oh, yes.
For a few reasons.
That's right.
They're easy to take care of, for one. They're pretty
so
robust.
easy.
Yeah, pretty robust for an amphibian. Like, they can tolerate being touched by a bunch of kids. And unlike some other types of frogs, they are pretty slow. They don't jump very high, so they're not going to escape super easily when you have them out on the floor.
True.
Yeah.
Right.
In addition, they have a lot of cool defenses that you can talk about. Because, you know, frogs and toads in general seem very vulnerable to predators. They don't have thick
Feel
skin,
squishy.
scales, teeth, claws, any of that. Yeah.
Right, right.
So we get to talk about some of the cool things that the toad can do. It's got that bumpy brown skin that's great for camouflage with the forest floor. They can puff themselves up with air to make themselves both bigger and more intimidating, and also more difficult to swallow for predators.
Yeah.
They can also play dead, since many predators only try to attack moving prey. And then there are those two bigger bumps on the back of their head, the parotid glands, that secrete a horrible tasting bitter poison that means most predators will only try to mess with a toad once. And of course, what almost anyone who has ever picked up a wild toad will have experienced, which is that they pee on you.
Yeah, they will.
I was waiting for you to mention that one. Whew.
And, that's a lot for one species of toad. Of course, other species of frogs have other defenses. Poison dart frogs are famous, of course, for their bright colors and deadly poisonous skins. And even non-poison dart species, there are many species of frogs that have some kind of toxicity on the outside of their body and their mucus to deter predators. More recently, I learned that there are several species of frog that can emit a very loud yell when they are threatened or surprised.
Awesome.
Which might be enough to startle a predator into dropping them. You can see some videos on YouTube.
Yeah.
Yeah. The main thing I want to talk about today, though, is an unusual defense that a few species of frog have developed, which is glue.
What?
Frog glue.
Okay.
Frog,
Yeah.
Frog glue? I've not heard of this. What? Frog glue.
Yeah.
This is
A
cool.
number of otherwise relatively unremarkable frogs and toads all can, when threatened, secrete a special white fluid from their backs that quickly becomes incredibly sticky. So field researchers that handle these frogs, like their fingers get stuck together, their fingers get stuck to their flashlight, their notebooks, anything they try to handle. Just like,
amazing.
That's awesome.
Yep. And interestingly, these species of frog come from widely different places on the evolutionary tree of frogs.
Huh.
So some Belgian researchers became interested in this gluing phenomenon and decided to do some research to figure out a bit about how it works. Because there's also generally speaking, there's a lot of interest in biological glues because there's all kinds of possible medical applications and other types of applications for these glues that nature has come up with, evolution has come up with, that can be used under conditions that it's difficult for things that we've invented to work under, like underwater, like mussels.
Yeah.
Mussels have these filaments that glue to rocks underwater, stuff like that.
Okay.
So, there's a certain amount of interest in how this frog glue might work. So first they tested the strength of the glue from the delightfully named Madagascan tomato frog.
That brings
Amazing.
such a great picture of this frog in my head because I think I do know this frog.
Yeah.
That's phenomenal.
Latin name Discophus guinetti. But it's a tomato frog. Tomato frog, it's kind of red and round.
You don't say.
Yes. They tested the strength of the frog glue by using it for, quote, mechanical pull tests using smooth-surfaced hard plastic blocks, unquote.
Okay.
In other
glued
words,
plastic together.
they glued
and
Legos together. They glued Legos together.
Legos? Nice.
Phenomenal. I love science.
And then they tested how much force it took to pull them apart. And they tested the strength of this glue at about 10 minutes and at 60 minutes of curing time. And they discovered that the glue became about twice as strong by the time 60 minutes had rolled around. Yeah. So when they pulled the bricks apart at 10 minutes, the glue tended to break in the middle. So part of the glue would be on each half.
Mm-hmm.
At 60 minutes, they'd have to pull harder, and the glue would just be one cohesive mass that would stick to one of the bricks.
Whoa.
Gotcha.
Yeah.
Wow. That's cool.
Yeah.
And they were able to do some analysis of what the glue was made of, and there were several proteins, and the main one had this very unusual structure in that it was kind of like cooked spaghetti.
What?
Oh, yeah.
Yes.
It's a long chain, long cross chain link polymer.
Long, floppy protein.
Huh.
So most proteins fold in a very particular way and have a fairly rigid structure because they have a particular purpose that they need to do, and it needs to fit with other things. But these proteins were floppy and long and noodly. The researchers compared it to a cooked noodle that has adapts to the shape of whatever you fling it against.
Uh-huh.
Okay.
In addition, there are a lot of sticky sugars attached to the proteins, and there are also other proteins that bind the noodle proteins to each other.
Okay.
All resulting in a very extremely sticky, pressure-sensitive glue.
Phenomenal.
You think about what would happen in a predator's mouth if it's trying to chomp down on one of these frogs.
You can't you can't open your mouth
glue your mouth
anymore.
shut?
Yep.
Yeah, and particularly for if you're say a fox or something, you can, even if you can't spit the frog out, you can probably use your paw to force it out. But
Yeah,
if you're a snake,
This seems
you might be in real
maybe
trouble.
Similar to the bad taste, in that it probably is not going to save the individual who's going to get chomped and then glue itself in your mouth potentially, but that animal will probably not. The predator will probably not try to go after that species again, right?
Yeah, but it might save the individual.
Really?
Yeah, because if the frog is in the mouth and is secreting this before it chomps down, it gets grabbed, it might have some injuries, but it's stuck to the roof of the mouth of the animal, then it can't be chewed.
I suppose, but I mean, how fast is the glue set up? I mean, I think about my dog. If she finds a baby rabbit in the yard, a nest,
Game over.
she will swallow them just whole, just chomp, they're gone. Right? There's it's a matter of seconds. They don't sit around kind of this is done chewing. It's pick it up, swallow, and you kind of go the glue would have to act so fast.
I think it does act
save
pretty
that
quickly.
individual. Oh, that's wild if it does.
Oof. Huh.
But the remaining question was, how did frogs that are not closely related come up with such similar glues? Because it's not only the
Yeah.
Madagascan tomato frog, it's like several other species.
Okay.
Yeah, it's like it's a convergence evolution thing.
So there's something
Well-
innate. Oh, can we kind of guess?
Go ahead, please guess.
Just from, knowing about like how things evolve, there had to have been something that all these frogs already have that can, mutate into this. But I'm going to guess it's something that normally serves another purpose that ends
Ooh.
up getting adapted to be this.
Would it be
That
like
happens
some
to be
sort of
present
like
in all the frogs.
mucus like membrane?
Yeah, something like that.
Well, it's a really good guess.
Are we wrong?
Not exactly. So they did genetic analysis and they figured out which genes encode these proteins that make up the
Okay.
glue. And actually, the genes are found widely across pretty much all the types of not just frogs, but amphibians that they tested.
Whoa.
Okay.
But it's not
Okay.
Brings up
necessarily
ancient-
turned on in all of the
Right.
species.
So the question then becomes, was this something that an ancestor had the ability to do that is still in the DNA but not utilized by
Well, that
all modern frogs?
seems quite possible.
Yeah.
Or is it something that was, as happens in evolution, it would the genes actually coded for something like
completely different.
unrelated, right? But then in some cases they can end up being used for a different purpose, like
Yeah.
I don't know, evolution is wild.
I don't think we know enough yet.
Yeah.
But it also
More studies.
leaves open the possibility that there are more living frog species that can do this that we
Can
just
do this.
don't happen to
Yeah,
know.
we don't know.
Yeah.
Very cool.
That's wild.
Yeah. Well, my sources this week were so this article that this research came from was called Recurrent Evolution of Adhesive Defense Systems in Amphibians by Parallel Shifts in Gene Expression from Nature Communications, July 2024 by Shabnam Zanam et al. And then there was a good article in the New York Times covering the research. And also I got some more information about specific defenses of the American toad from the Virginia DWR.
Okay.
Very nice.
Love
All
it.
right. We are going to take a quick break, and when we come back, it'll be Kirk.
Hey everyone, we are back. And last week on the show, I talked about the volcano that spews gold. And so I
Yeah.
thought this
Yep,
week,
you did.
I just want to take a look at gold in general. Because
Okay.
it's wild, you guys. So humans first started working with gold, we think about 6,700 years ago.
Ooh.
And we were first attracted to it because it's shiny and beautiful. Yeah,
We're
I
like
gotta say-
crows. We like shiny things.
Sure, and I get that. I will say, I have to admit, I've never really been like a gold guy myself.
No.
I'm not super into like the color. I think probably because now it has somewhat connotation of being a little gaudy sometimes. Because like we can produce fake gold things, and so it's like, oh, gold. Okay, it's a little, you can get gold anything. It doesn't necessarily mean it's actually gold.
Mm-hmm.
And like my wedding band, for example, is titanium. Not gold. So like, and my wife's is like platinum. Like we're just not gold people, but I get it. I get the appeal.
Yeah.
And one of the things that I find fascinating about gold is that it's always been valuable, or at least it's always been valuable since we knew about it. And we can't manufacture it. We can't make real gold like on our own. If we look at something like diamonds, their value is completely inflated. Like they really aren't all that rare at all. There's basically a global price fixing monopoly on natural diamonds. Like
Right.
that's there to keep
Yep.
the price high, even though they really aren't that rare. And they're used industrially as like sandpaper, basically. So like they're, diamonds are not all that rare. But on top of that, we can also like produce amazing lab grown diamonds now that are just as good or not better and higher quality and cheaper than the actual like natural diamonds. And we can't say that about gold. Like
No.
the price is just the actual price to extract it. If it costs, find a way to make it for less, and the price goes down, and we get more of it. If we have less of it, and it's a simple supply and demand kind of thing.
Well, alchemists spent centuries trying to produce gold from other things and
They
failing.
did,
did.
and were
Famously.
super, unable to do it because they didn't understand that you can't just like, you need to actually change the atomic structure, and it's
Yeah,
turns out a little
that's
harder than just
that's a little
simple
tough.
chemistry. So I mentioned jewelry, like I mentioned, like rings and things earlier, and jewelry is actually still the largest use for gold that we have, with 2,000 metric tons used every year just for jewelry, which is astounding. I was like, oh, it can't be still for jewelry. Can't be. Nope, that's it. That's still our largest use for gold.
Wow.
But it only makes up 44% of the gold used. So while it's the largest single use of gold, when all the other uses are added up, they become more. So before I actually looked at the data, I was trying to figure out like what they could possibly be, like what was all the gold being used for.
Yeah.
Like I know gold is used in technology, like computers and phones and microchips and things like that. Gold is a absolutely fabulous conductor of electricity. And it doesn't really like have some of the problems other metals do. So it gets used a lot in electronics.
Yeah.
But I was surprised to learn, it kind of blew my mind, only 7% of the annual production of gold goes to electronics.
They
So
only
we
have to use
7%.
tiny amounts.
That's true. And that's probably what it is. It's tiny amounts. So
Yeah.
we have 7% plus 44, and we've accounted for only 51% of the gold. Almost half of it is still missing. Can either of you guess where it all goes?
Well,
Like,
there's dentistry.
I was you beat. I was literally going to say, I'll give you a clue. It's not tooth fillings.
Okay.
Well, that's
You took it
good.
right out of my mouth. That does not even make the list. That's
right.
so
Okay.
insignificant. Doesn't even make the list. So
Rockets.
not rockets. No.
Plating Donald Trump toilets.
I mean,
Oh. I think that would count as jewelry. I guess.
I
probably the
suppose.
Decorative
Yeah.
elements.
Yeah.
Yep.
So I'll tell you,
The
the
new White
answer
House
would make.
ballroom.
I'll give you a clue. The answer would make dragons proud.
Ooh, money.
Well,
bricks.
hoarding.
Yeah.
Hoarding, basically.
Hoarding.
Yeah.
Okay.
Something humans have always done with gold for centuries, just collect it up and lock it away. About 26% of the gold is held onto as an investment, which leaves about 23%. And frankly,
Whoa.
I kind of consider it to be the same answer. It's just governments doing it. So gold is held by central banks to prop up currencies and stabilize economies, which is basically kind of a form of investment on a much, much larger scale and for a different reason. And I'm sure some
Yeah.
economists would love to debate me on my characterization of that. But it's, those two together make up the rest of what we use gold for. So gold is something that humans really want. We assign a lot of value to it. And it turns out there is a ton of gold on Earth, or rather, there's a ton of gold in the Earth.
There it is.
There's a really big problem, though. If you want to get all the gold on Earth, most of it is simply just impossible to get to. And I don't mean difficult, I mean impossible. And to
Okay.
understand why, I think we need to know more about gold. So remember how I said that we can't make gold?
Right.
I think I maybe did hear that some scientists recently did make like an amazingly small amount of gold, like microscopic amount, like in a particle accelerator or some kind of thing where they were actually able to add, neutrons to something.
Sure.
And it was an experiment, but
Yeah.
it was not it wasn't practical, right?
no,
It's not
you're
actually
using a particle accelerator to make a minuscule
proof of concept
amount.
or
Yeah.
something similar. Yeah. So there isn't any practical way to make gold. Gold is a pretty heavy element. A cubic foot of gold, if you can picture that, weighs 1,206 pounds.
Oof.
Just a
What?
cubic foot. Yeah, a cubic foot of gold weighs 1,206 pounds. And for comparison,
Holy
a
shnikes. That's just so
cubic
much.
foot of iron, when I think of iron as being heavy, a cubic foot of iron only weighs 491 pounds.
Yeah.
So you see that
only weighs.
gold is really, really dense.
Wow.
And when we think about how elements like gold are actually made, we have to go to nuclear fusion. So our sun uses the enormous heat and pressure of gravity to press hydrogen atoms together, and they fuse together to make helium. And if you fuse, for example, 2 helium atoms together, you get beryllium. And stars, what they do is they keep fusing heavier and heavier atoms together as they get further on in their life. A lot of them happens like right at the end as they run out of fuel. And basically, this keeps on happening where heavier and heavier atoms, get fused together until they kind of hit a brick wall, or in this case, an iron wall. It turns out that that's where everything stops. Like a star like our sun simply cannot fuse together anything to make something denser than iron.
Oh.
But keep in mind, though, we said a cubic foot of iron weighs 491 pounds. While a cubic foot of gold weighs 1,206.
Yeah.
Gold is way heavier than iron, which means you can't make gold in the sun. There's lots of elements you can't make that way. There's actually 66 naturally occurring elements, everything from gold to platinum to uranium. None of these can be formed in a star like the sun. So where do they come from?
Yeah, how do they get made then?
Yeah, well, the answer is even more exotic and wild than being formed in a sun by fusion, by stellar fusion. Elements heavier than iron are formed in supernovas. So when a star goes supernova, the incredible forces involved that can actually fuse together those heavier elements in a brilliant, explosion. And we think this can also happen when 2 neutron stars collide with each other. And so here's the wild thing. Many of our listeners right now are wearing gold jewelry right now, maybe a gold, ring, or gold earrings or something like that. Maybe a gold watch. Yeah, there you go. Well, or maybe you're just listening to this on a smartphone, right, that has gold in it. There's a few milligrams of gold in each phone. All of that gold was created in a supernova or similar cosmic event. So if you're looking at that ring, it's like, this gold was literally made in a supernova, not in our solar system, because our solar system didn't exist yet.
Yeah.
Which is just bonkers and blows my mind. So if you hold on to a gold ring, you're literally touching the result of a supernova.
It's hard to wrap my mind around.
Right, because you're like, well, but I'm on Earth. Like, how does it get to Earth? So keep in mind that when the Earth formed, it was essentially elements floating around in space that coalesced into a planet. And we think this is over a time period of something like 10 to 20 million years. And all this dust, essentially like silicon and aluminum and carbon and plutonium and aluminum and gold, was all drawn together into progressively larger and larger masses that kept merging and merging and merging and eventually forming a planet. And there's a problem with that, though, because remember, gold is really, really, really heavy.
Yeah.
And essentially all of it sunk to the core of the Earth.
So, okay.
99% of all the gold currently on Earth is in the Earth's core. And the core is mostly iron and nickel. And the gold, these trace amounts of gold are just mixed into that iron and nickel core.
Hilarious.
And one
fun
fun statistic is that if you took all of the gold in the core of the Earth, you could cover the entire surface of the Earth in a 50 centimeter thick layer of gold. That's a lot of gold that we just can't get to.
That's so funny, Kirk. That's hilarious. No.
We're not going to try that.
We better not.
I'm just saying that's how much we think is there.
Whew. Okay.
And again, that's not possible since there's absolutely no way to get to that gold. It's just completely impossible. We can't even get close because the heat and pressures at that depth are mind-boggling. We can't even get they're close to those kinds of depths.
With compaction and no.
Yeah, we can't really even drill all the way through like the crust of the earth, let
Right.
alone through that and through the mantle and get to the core and then somehow
Yeah.
extract gold from that. No, it's not happening.
I think it would
That's-
melt our drilling equipment for
Yeah, we don't
starters.
have
the drilling equipment melts before you can even get to the mantle.
Yep.
Like from the heat. So one thing I found really interesting reading up on this for this episode is that if the gold is heavy and it sank to the core like long, long ago when the planet was forming, then how do we have any gold at all?
volcanoes.
Shouldn't it be at the core? Well, we'll get to that in a second, Rachel, but part of the answer is that once the earth formed and had like a solid surface, it was formed enough for that, and they started to cool, and okay, now we have like a crust forming. The earth continued to be bombarded by meteors for millions of years.
Okay.
And these meteors
Yeah.
had gold in them too. And so we think that a lot of the gold that got incorporated into the crust of the earth was the gold that was deposited after the crust had like formed early on.
Okay.
It's like,
So
okay, that's pretty cool.
So the gold that we use mostly in our like cell phones and technology and jewelry was made in
Yes.
a supernova and then deposited on our planet
Coalesced
via-
into like meteors that
And
then
then-
crashed into the earth.
and broke apart into the earth to then become part of our crust.
Yeah. It's so cool.
Okay.
So there's a ton of gold in the earth, but not on the earth. And we actually, like I said, we used to think that it all came from meteors that hit the earth after it had solidified. But there was actually a new study, though, that just came out where researchers were able to show that some of the gold, at least some of it, that comes out of volcanoes does actually come from the region where the Earth's mantle touches the Earth's core, 1,800 miles below the surface. So basically, I don't know if we even really understand why, but we think that gold is leaking out of the core, getting mixed
Sure.
with the mantle, and being transported to the surface via deep mantle plumes to volcanoes like Kilauea in Hawaii, which is where this group did their research and study. They actually just published their research in the May 21st, 2025 issue of Nature. If you want to read it, it was called Ruthenium and Tungsten Isotopes Systematics in Ocean Island Basalts Reveals Core Leakage. They're mostly looking at these other two elements, but gold was sort of implicated in this as well. And so it's like, wow, there's actually, our core is leaking. We have a core leak, you guys.
sounds bad.
Leaking
that
gold.
doesn't sound great.
Alert, core leak.
Danger, core leak, gold leaving. So like basically we're still learning more about this, and it's an absolutely wild journey that gold takes. Rachel, you're talking about the whole thing. It's like, well, it could be even weirder because it's like it gets stuck in the core of this planet for millions and millions, or like billions of years, and then slowly leaks out, comes up through a mantle plume into a volcano, and that volcano then eventually gets mined by humans, and we get gold. Like guys, gold is amazing. The more I learn about it, the more I'm like, this stuff is super, super cool. And by the way, so my final thought on this, because I'm going a little long here, is I'll leave you with this thought. Like, gold isn't ever really destroyed. All the gold that humans have mined on Earth is pretty much we still have, because it just gets recycled into other stuff because it's so valuable.
Yeah.
So if you took all of the gold ever mined by humans in the entire history of the Earth and melted it into one single monolithic cube, it would only be 71 feet or 22 meters on each side. It'd be like a 71 or maybe it was 73 foot
Oh my
cube.
goodness.
And I somehow find that almost more amazing than knowing it came from a supernova, that like all the gold only makes up this cube that would like fit in the park down the street. Like that's just, or fit in some people's front yards. Like basically like that's
Oh, wow.
absolutely, and that's all the gold we have. So that is bonkers. Our planet, our universe, it's all strange. It's all amazing. My sources this week were Statistica, gold.org, Live Science, and the journal Nature. That's what I got. We're going to take a short break, and when we come back, we'll have Rachel.
Whoa. Welcome back to the show, everybody. So, Kirk and Victoria, do either one of you donate blood?
Well, not
Kirk's
recently.
face right now.
I
It's like
know people who donate blood. I
I-
personally am not a blood donor. I don't do great with having a lot of blood taken out of my body, so it's
Mm.
probably not for me. If
Yeah.
a loved one needed it, I'd be there. I
Yeah.
salute those who are able to do that. Yep.
Yeah. So for me, I try to donate blood. I used to fairly regularly donate blood, but it's been a long while since I've done that.
Okay.
To contribute to blood banks, to help with transfusions and things.
Yeah, it's awesome. It's a huge thing.
Yeah, it is. But I want you to think about it for a second. How wild of a thing to do. I'm going to donate my blood
It's wild
to
for sure.
put into somebody else's body, so that way you can replace blood that is either like has gone bad, or like if they've lost a bunch of blood, like to replace it so that way they don't die. What a wild concept, right?
Yeah.
Yeah.
Objectively. So with that thought in your heads, when do you think the first blood transfusions were done?
Ooh.
Mm.
Successful or attempts?
Yeah, that's a great question. Successful or
Yes.
unsuccessful? Yes. If you're gonna pin me to it, I'm gonna say in the 1800s sometime.
Okay. Victoria?
But I'm guessing since you asked the question, it's gonna be like 1000 BC.
I remember reading. I think there was some like 1920s attempts before they figured out about
Blood
blood
types.
types,
Yeah,
and they
that's a
you
big
know
sticky wicket right there.
they tried animal blood transfusions, and that didn't go so well. And
Oh.
I don't. Yeah.
Beautiful. I love this. So phenomenal. So blood has been long known to be a really essential part of the human body, and that
Yeah.
with it was thought to be like the essential, most pure element in the human body for a very long time, like medieval ages. Bloodletting was a huge thing, especially in medieval times. The earliest accounts of actual blood transfusion, the first official one, was done in 1667.
Okay.
Ooh, wow. Okay.
How did that go for them?
Well,
Yeah, how'd that
okay.
go?
So, at this particular now, I want you all to think about this. This is before we really learned anything about blood, and we
Yeah.
didn't know about blood types until 1900. Okay,
Yeah.
that's when that was discovered.
Yeah.
So, in 1628, William Harvey, a physician, he figured out that blood circulates through
Yeah.
the body, and
Yep.
that it doesn't just
Yeah.
stay in one place. Now we're saying, yeah, but this was revolutionary at that point in time. So they,
Okay.
following that, doctors started to figure out, and started to think, well, if blood circulates through the body, maybe we can use it to help balance the humors within the body.
Yeah.
Yeah. Humors aren't a thing, but they started to think, what can
There
we
is
do
that
to maybe
one small
help?
little problem, right?
Of course, they didn't do human-to-human transfusions at first. They did animal-to-animal, and after that was successful, they did animal-to-human transfusions. Physician, well, okay, yes.
Great way to make new diseases.
Well, yeah. So physician John Baptiste Dennis was the first one to do this in 1667, and he gave a man who was suffering from fever new blood. He gave him about, I think, 12 ounces or something like that of blood from a lamb, and the man seemed to recover. And he did.
Yikes.
So he was
Yikes.
successful, and then he did it again. However, his third and fourth attempt did not go well, and the patients died during the transfusion.
Stop, dude. Stop.
Yeah.
And the wife of the fourth patient actually had him brought to trial for murder. It didn't go super great. He was charged with murder. He was found not liable for it.
Okay.
But
Okay.
afterwards, it was, banned for a good reason, but that was a number of years later that the practice ended up being banned. People didn't really think it was a good idea to have,
and it wasn't,
blood from one side to another, and like it just was not well done. So he was cleared of wrongdoing. So the court in France ended up banning the practice of it. The Catholic Church and the Royal Society also banned blood transfusions, and it stopped until the mid-19th century. Now, here's the thing. One of the applications that was done one of the reasons why they wanted to do blood transfusions or thought it would be able to help was to treat, one of the treatments, I should say, was that of psychosis. Okay?
Okay.
Wow.
I guess I could see where they were coming from in the fact of, like, okay, something is wrong with their brain, so maybe whatever is circulating through their body could be contributing to that. So it's a very entirely possible why that would happen. Now, here's the thing, is especially in the 1600s and even the early 1900s, when we were just getting started again with blood transfusions, psychosis was a really general term for many things.
Sure. Yeah.
But one of the causes of some psychosis, especially in the 1900s, was syphilis. If you can get...
Oh, my.
Yeah.
Yeah. So if you have syphilis for a long period of time, for those of you who don't know, syphilis is a sexually transmitted infection caused by bacteria. And what would happen is eventually you'd start off with sores, and there's like 3 to 4 different levels of syphilis.
Stage.
Yeah, so there's like a primary, secondary, a latent form, and then there's tertiary. So if you go untreated from syphilis, like eventually you can die, but it also, like, if you don't get it treated, latent and tertiary symptoms are like 10 plus years down the line, okay? So it takes a long time for those symptoms to particularly develop. And those symptoms tend to be those that affect the heart and the brain. If it starts to affect your central nervous system, it could affect your behavior, often presenting itself in psychosis. So people thought, like, hey, well, if we take what is circulating around, what if we take out some of the bad blood? Because at this point in time, we're still working through non-humor related humors were still a thing at this point in time. Right. So like it wasn't, we weren't sure about bacteria. So I'm getting a little off topic. So what is happening is they wanted to treat psychosis potentially with the blood transfusion. So get out the bad blood, put in some new blood that you know is good, so that way you don't have to like have this sick blood going through your body. Now, remember,
kind of makes sense.
Syphilis is
from
caused
their perspective,
by a bacteria.
Yeah.
And one of the symptoms of a blood transfusion, when you don't know about blood typing and you just give someone a different blood type, you end up with a rejection. You often end up with a high fever. Fever then gets burns up the bacteria that's causing the infection of syphilis, and thus seemingly cures you of psychosis. So they had a weird and somewhat wrong method wrong methodology around this, but they got the result.
If it didn't kill you, it made you better.
It's a little bit wild. Like, obviously it didn't work all the time, but to look at someone be like, who's clearly has psychosis, and that's what they called it at that point in time, and then be like, you know what they need? Different blood. And then it works. Obviously it didn't work all the time. It only really worked if it was being caused by syphilis or other bacteria infections.
Yeah.
But
and it'd be so hard to tease that apart.
The history of transfusions is pretty wild, and it's pretty interesting. But I learned that I heard that little fact, and then I did more of a deep dive into blood transfusions and the history of it, and I was like,
wow.
Well, I guess I know what I'm talking about this week. So that's what I have for you both this week, is a little bit of the history of blood transfusions and what they were used to cure, I guess? To treat, I should say.
Yeah, kind of.
Sources this week, I got some basic information about syphilis from the Mayo Clinic as well as from Wikipedia. The history of blood transfusions, there was a paper in Science Direct, the earliest blood transfusions in the 17th century in Italy. There was also a paper in the National Library of Medicine called The History of Fluid Resuscitation for Bleeding. And let's see, Britannica also had a really good, The Strange Grisly History of the First Blood Transfusion. They even have the date. It was June 15th, 1667. Wild. Then I also used the Association for Advancement of Blood and Biotherapies, Transfusion Medicine History. And then the Red Cross had some really cool information as well. And I believe that wraps us up this week. Yeah. So thanks everyone for listening. We'll see you all next week. Bye.
Bye-bye.
Bye-bye. Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.